Hello everyone, and welcome to the transit and the maintenance, transit operations and maintenance tech talk that we're having today. My name is Beazley, and I'm the product manager for AssetWise Asset Performance Management, and in particular the asset reliability component of the AssetWise solution. This webinar is intended to be the first in a series for transportation asset management. There are many industry segments, audiences, and businesses with issues to address in this transit and transportation sector. The webinar will address benefits that transit operators will realize from a comprehensive information system for both operations and maintenance management of the permanent way. We'll also have future webinars focusing on rolling stock, highways, etc. These are also the typical challenges for transit, not just transportation industries. Many people have to deal with a limited budget. They're being asked to do more with less and repair existing equipment versus getting new capital investments for new equipment and transit assets. Safety is, of course, very important, and we're going to highlight this as a workforce safety topic throughout the webinar. Safety critical assets are also very important, and the impact and consequences of closing them down and shutting down the operation, which leads to downtime and disruptions management, improvement and reduction. We're trying to help people move from a firefighting mode to one that's data driven in terms of the decision making that multiple departments have to do together as they work on one area or right of way or one rail corridor. Access to information across these departmental silos is a challenge, and trying to make decisions based on things like cost per unit of traffic and feed the maintenance schedule to the traffic schedule is what we're trying to depict and how to help solve those problems in our solutions. We have many users who have been realizing savings and efficiencies from a combined information system. And here are just a few highlights popping up on the screen. The savings are substantial, and the improvements represent a large business opportunity for our users and yourselves. But really, we're trying to deal with the information and helping the various roles. But how many roles are responsible for managing the permanent way in a transit authority? Well, as you can see on this slide, there are a vast many departments and roles listed. I won't read them all, but you can see that each individual role has various information needs, and these roles also will perform better by working together as opposed to in their own separate little environment or data management system. So let's start with the GIS team. The GIS team is responsible to document the various fixed and linear assets in various electronic formats. The leading information systems now present the assets in an interactive and usable format like these two screenshots on the top. The lower right one is a linearized track chart that shows the lanes, mile markers, and the fixed assets along the permanent way. You will see this chart many times throughout the examples in this webinar, and it's really to make this effective in helping the various roles work together and see the entirety of the work to accomplish in a safe and efficient manner. The track inspector has many details to manage. Information around rail profile, rail roughness, weld condition, curvature, overhead wire height, stagger, parallelism, wear, degradation, and defects, etc. Much of this data comes from the diagnostic vehicles that are periodically sent along the track to collect these various measurements. Some of the data is also from visual inspections and defects recorded along the way by inspectors who go out and walk the track. The track inspector also has a lot of measurement data coming from those diagnostic cars, but these measurement data pose particular challenges due to the measurement location and linear referencing. These can cause data errors such as reproducibility, needing to realign the defects to the actual locations by realigning the data sets. Maybe the starting point of the measurement was slightly off from the previous one. So our solution helps realign these data sets and remove the spikes, or make sure that the actual data is in the right orientation so that we can see spikes grow or new spikes come up. It's all about having better trending from the time series nature of these measurement files and improving the forecasting by looking at multiple files to help plan repairs and also CapEx spend. The track designer provides much of the design and attribute data for the other parties and roles responsible for the permanent way. However, the track designer is typically not only responsible for the track layout, but also for adding new lanes and ways. They're often responsible for also detailing the tamping plan, which you see down at the bottom. So in the green and yellow sections on that bottom right screen, you'll see that they are seeing the ultrasonic measurement data from the diagnostic vehicles, and from this they can consolidate the tamping analysis so they can design the tamping plan and also improve future track design. The track designer and the track inspector also have a lot of graphical information at their fingertips. The key is to have a comprehensive and effective information system that supplies this to them via a few clicks. So the staff should be able to click on an object in one of the linear chart screens and then be able to see, for example, the pop-up window of the point cloud showing all the other assets and physical items around the track when they're trying to decide what to do. Things like bridges, culverts, overhead structures, trees, vegetation, buildings, and so on. Having this visual tool allows everyone to work more easily, intelligently to manage the congestion and develop safe work plans. Now, the bridge inspectors typically play a separate role, but in a transit authority, their structures are very large and complex or relatively simple, but they interact with the rail roles that we just described. They're also really important for disruption control and making sure that the people are inspecting the track and the bridges at the same time to watch, that they don't take the railway down twice in a short period of time when the work could have been consolidated. So the bridge inspector needs tools to define their inspection route on a map, to view inspection history, and also report much of the information to the proper regulator in the proper format. For example, the National Bridge Inventory here for the United States. As I said earlier, a lot of data can be collected by walking the track via mobile inspections. In this case, we're showing the bridge inspector using their mobile device to go and collect the information in a disconnected mode. So they need to see the assets to make sure they're at the correct location to perform the inspection. Then they need a list of attributes and details to ensure that they're making the right inputs and decisions when they do the inspection. While performing the inspection, they should have predefined pick lists so that everyone's collecting the same type of information, which improves reporting across the asset classes, and that the data becomes more consistent, repeatable, and useful. And this type of mobile interface would also be useful for other roles in other departments. For example, here's a screen in which people could be taking a look at the fixed equipment along the way, such as the signals needing failure finding and testing, the switch inspections like the cycle times, the mechanical condition, and other tests being documented in a very quick data entry manner. You've also got substation inspections, transformers, circuit breakers, as well as the crossing arms at all the intersections, where we might again look at cycle time and mechanical condition. There's many, many more. These are just a few examples. The maintenance gang, or the maintenance crew, and the maintenance planners have a huge gain, or can gain a huge benefit from an effective information system. For example, seeing the congestion of the planned work and the break-in work, the inspections along the linear track, and that helps them determine their plan of attack to get all the work done on time. Having the ability to click and open related design and engineering data sheets, procedures, manuals, and CAD drawings allows for good planning and improved safety at the job site, ultimately improving the percent work time versus the walking around and trying to find out the information that they're looking for. I apologize. I have a little bit of a head cold today, but I'll try not to cough too much. So even when things go wrong, a comprehensive information management system can help. One of our users had an instance where the gang arrived at a location with the incorrect equipment to do the job. However, they were able to look at the other work in the backlog on the linear track chart and then do a different job with the equipment they had on hand, so their travel time wasn't wasted. Supervisors and managers and directors of asset management have also the need to be able to see higher level summary details to manage the big picture and the objectives of the transit organization. They need organized information to help them make informed decisions about the present condition and the future expenditures to ensure safe, reliable, and cost-effective transit. So ultimately, this is where it all comes together. Somewhere along the permanent way, we have to organize safe and optimized work. So to do that, we're suggesting that the best approach is to have a comprehensive information management system comprising of these elements to enable the workforce to effectively execute the inspections, the condition monitoring, analysis, and forecasting to ensure the highest performance of the transit system in total. So it takes a lot of different activities and information system capabilities to drive this, but I'm going to go through them in the next few slides. So a system, like I've been illustrating previously through this webinar, uses a very significant case example where it was used in a significant pilot. The pilot covered 47 route miles of commuter passenger line and was subsequently expanded to 80 additional miles of track that services intercity and freight traffic. The resulting savings over the entire zone, resulting in per mile savings in the range of 5,000 to 10,000 pounds per mile per year over a 5-year period. These savings reflected an annual average of 8 to 18% of combined capital and maintenance expenditure improvements. It did not include the costs associated with reduced derailment potential. A comprehensive information management system for transit should have these capabilities to support the business processes required to manage the operation and maintenance functions. Building the foundation of asset lifecycle information management, then moving to managing asset performance, reliability and integrity, and safety today and into the future with asset performance modeling and asset optioneering. I'll go through each of these in a little more detail in a second. So the other part of this information system is that asset and infrastructure projects are not isolated events, but they live within a life cycle view of the entire asset. Bentley's ProjectWise and AssetWise suite of products enable organizations, regardless of whether they're in the middle of CapEx or OpEx stage of life, to manage their information securely while minimizing their long-term risk and investment. Let's look deeper into the asset lifecycle information management capabilities of AssetWise. AssetWise provides a vast amount of capability sets for transit owners to manage and improve operational performance. AssetWise operates within the owner common data environment and interoperates with other business systems in this IT landscape. A suite of capabilities allowing asset-centric businesses to optimize asset performance and business outcomes. AssetWise spans the TOTEX lifecycle and enables one view of information for all workers and minimizes the rework, the handover, translation of information, and integration. Handover will be key to the effectiveness of any new expansion or modernization of your organization that it might be contemplating as you expand to new neighborhoods or new communities. Asset reliability is a mainstay of the operational phase of transit assets. The key to operating your transit assets reliably is to understand the business risk that those assets posed in terms of the consequences and likelihood of failure, and to define strategies to mitigate this risk. These strategies, in the first capability set, strategy development and implementation, are developed using various methodologies, including failure modes and effects analysis, SysSIL per the IEC 61511 standard, which would be especially important, I think, for signaling systems. It also uses a lot of staff and industry knowledge to comprise these failure modes and strategies for risk mitigation. The outputs of these strategies include inspection plans, condition monitoring, preventive maintenance. The condition and inspection and measurement data collection also needs to be managed and consolidated into one system so that the health monitoring, alerting, and corrective actions can be managed and approved. Many of you probably already have a work management system, a CMMS, an EAM, or an ERP that will do these functions shown on the next slide. However, if you don't have one, AssetWise has a system to bring to bear on your organization. So typically work management involves the integrated functions of work planning, inventory, and procurement. The key is to feed this part of the process, with the right work at the right time, coming from the strategy development stage of reliability. As you've seen in this webinar, the proactive way to determine the right work is by taking a data-driven approach. Work planning involves labor, parts, services, and tools. Work scheduling involves crew capacity and availability-based scheduling, work assignment, resource leveling, and managing groups of crews to get the job done on time. And then the work order actuals part in the follow-up and closeout is the time entry and issuing the parts to the work order to collect the full cost of the job, and noting also, which failures occurred and were corrected. Here's an example of one of our users using parts of this system. Utah Transit Authorities using our had a problem where they wanted to be able to better manage and achieve their state of good repair, comply with the Federal Transit Administration's requirements for MAP 21, and they wanted also to be better able to manage and document, especially for reporting purposes, their bridge inventory, track their inspections and maintenance, categorize and record their deterioration and condition rating, and to mitigate the risk. The benefits were reduced costs. They were able to mitigate and reduce the disruption of service and improve that towards running the transit in Utah much more cost effectively. This resulted also in higher customer satisfaction and avoiding loss of ridership. Network Rail also used our solution to deliver best practices in operational analytics. They needed to have a support system for improved decision making, to gain better understanding of the rate of asset degradation, and thus have more effective interventions and more timely preventive intervention to reduce the number of asset renewals and refurbishments. They use the AssetWise solution, including asset performance monitoring, analytical modeling, and decision support and analysis. This ensured higher customer satisfaction, reduced operational costs, and reduce risk and improve safety.